My workflow on this project begins with TMPGEnc. This software is the closest I've seen to a universal decoder-encoder and can handle the largest variety of files I've found. After launching the program, click on Start a New Project, and then Add File. In this case, I'm importing an .mts file from the flash drive of my Canon HD camcorder. The MTS, or MPEG Transport System, is a container for the raw video data. After the clip is loaded, we're taken to the Clip Properties screen. It's a good idea to make note of the information in the Clip Settings box for later reference. The next tab is for Cut Edit. In this window, you can play back the video clip frame by frame in order to trim and edit it. After this edit, the clip should have only the frames that will be used in the final video. In this case, I need to trim only the end portion, so I first set the end frame with the end bracket. This is where I want the video to stop. Then I make the cut. The Filters tab includes the Picture Crop tool, which is used to remove any non-green screen portion of the video clip. When cropping the four sides, notice that the video dimensions are also changing. Other useful filters include color correction and noise reduction if needed. Clicking OK in the filter window returns you to the main screen. Now we click on the Format tab, which calls up a list of preset formats that come with the program. I choose QuickTime for two reasons. At the end of this process, its H.264 codec produces the highest quality of video for the web currently available, especially on YouTube. Second, the compositing program I use requires either QuickTime or AVI, and AVI can be very awkward to work with on a computer that is not set up as a dedicated video workstation. Clicking Select takes you to the Formatting Settings window. Here, under Video Codecs, clicking on Settings takes you to the Compression Settings dialog box. After considerable experimentation, I have settled on Photo JPEG for rendering at this stage. Photo JPEG is a 100% or non-lossy archival setting. And my rule so far is never to lessen a clip's quality until I have to, which comes in the final render for the web with the H.264 codec. Clicking on the Encode tab at the top of the window takes you to the last screen. I click first on the Preview icon, the round one on the right with the magnifying glass. As you see, it's now necessary to adjust the video's rendering dimensions until there is no black border on any side. I look at the amount of black border, the number of pixels, and try to guess how much to trim using the earlier dimensions I recorded in the Cut Edit stage as a guide. Clicking on Format takes you back to the Settings screen. Here I enter new dimensions and see how close they get me to having no black border, only green. Now the work becomes a back and forth process to tweak the dimension settings so that there is no more black. Once this back and forth process is complete and you're ready to render and encode, click on the Encode icon on the far left. Now it's time to record our Second Life clip. Sizing the Second Life viewer for recording is an important step. If the final use of the video will be on the web and YouTube, you have two basic choices. First, the standard definition 640 × 480, width and height, or high definition, which is 1280 × 720, which YouTube also accepts and supposedly broadcasts. My test so far with YouTube's high definition function is that it does give a superior picture to standard definition, more detail, but not enough to make up for the bandwidth issues a user encounters when trying to play a YouTube video in high definition. As a result, my final render will be the standard 640/480. That size can be difficult to work with on a screen, although it is fine for viewing, so I set the viewer at one size larger, 960/720, which has the same proportions as a 640/480. For my Second Life screen recordings, I use Fraps, an inexpensive piece of software that was developed for benchmarking in the video gaming industry. Fraps can record any video game being played on a Windows computer at speeds up to 60 frames per second, and Fraps saves the capture as an AVI file. Also, Fraps uses only 1/100th of your computer's resources when compared to Camtasia, thus giving smoother screen recordings in Second Life without jitter even at 30 frames per second. As you can see, I'm also going to play back the green screen clip as I record in Second Life. Doing so allows me to better time the actions in the two clips so that it is easier to composite them in the next step.